So a couple quick announcements before we get into the material today. Although the announcement slide says differently, we're actually going to start arrays today. I finished all the material and classes that I want to cover for now. We need to get into arrays in enough time because homework 9 is going to be on 1D arrays, homework 10 is going to be on 2D arrays. So I want to be sure I introduce that material to you in lecture so you can go over it in lab, and then we can give you the homework on that. So let's see, we're going to be talking a bit about homework 8 today. Going to give some reflections on how well homework 7 was received. So we're going to talk about that. The grading guidelines for exam 2 will really be up on the website soon. You get 10 days after the grading guidelines are posted to turn in your regrades. So it's not like, I'm going to put it up and the next day is the last day for the grading regrades to be turned in. Next Wednesday at 10:20 a.m. I am getting dunked. If you want to see it in person, because I'm told it's going to be videotaped and put on YouTube, feel free to come see me. You can support whatever organization is funding it. I actually don't know what it is. Vent your frustration at homework 7, 8, 9, 10, all the way through 15, and try to dunk me as well. I will warn you that if it is 44 degrees out like it is right now, I am not going to get dunked because I will just freeze and die. And I've left explicit instructions if I die and you all enjoy it that you're all failing. So anyway, come see me get dunked. We don't know where it is, but as I've said before, I'm assuming a dunk tank is kind of hard to hide in the engineering complex. But they told us when we had to be there, but not actually where we have to show up. I assume it'll be there either on the main path through the engineering complex or maybe Darden Court, which is in the middle of Thornton, the Thornton building, the courtyard in the middle. Blah, 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 blah. Okay, any questions or comments about this? So I wanted to spend a bit of time talking about reflections about homework 7. So this is the graph that lists all of the homeworks. Yeah, well, funny you should say that. We're going to get to that. Don't worry. And homework 7 is the bright yellow one. And it wasn't quite as bad as some of the other ones. But yeah. It wasn't quite as bad as some of the others. And it's really interesting seeing some of the comments that are turned in. Because the comments earlier in the week and earlier in the day on Thursday would say things like, this was hard, it's a little bit unfair, I learned a lot, difficult but good, things like that. The comments on later on Thursday, towards the middle of the night of the Thursday, I sensed a slight bit amount of frustration. And here is a selected comment that I received very late on Thursday. So are you going to sound like you're not gonna. Yeah. When I get bad comments, apparently I really get them in style. There certainly was some frustration with homework 7. Some of it was understandable. I'm going to spend some time talking about it. If you are frustrated with it, so first a couple of things to lower the frustration that I sensed that this person felt. So we talked about the problem with staffing Thursday night with more TAs. The engineering school the engineering school wanted to give me, I kid you not, they wanted to give me like 4 TAs, like for all of you. And I just kind of threw a bit of a hissy fit and got the 17 TAs. But as you see that it's still not quite enough on Thursday night. And during parts of Thursday night, we have like 3 TAs there. No matter how many TAs I stock there, and I have put more there at times, not this semester, it's still never enough. Because the more TAs I put there, the more people wait until Thursday night, and then there is even more people who complain that there aren't enough TAs on Thursday night. In general, working on the homework earlier in the week or earlier in the day, there's much fewer TAs. The TAs Monday night are lonely and waiting for you to show up and ask them all the questions. And of course, this was slightly complicated by the fact that I didn't actually get the homework out until Sunday night. And for that, I do apologize. That was a definite screw-up on our part. And let's see, homework 8, I'm going to go over today. It's really all ready to go, so I'm going to link it today. It's actually at the right URL. It's just not linked to from the homeworks page. Not surprisingly, these homeworks are going to be a bit harder than the others. We very intentionally are not giving you as much detail and having you fill in the remaining detail. And this is, well, probably not what this person was frustrated about, but I know that there were a lot of people that were frustrated on that. And to a certain extent, it's a balance on our side because we need to start getting you, I mean, to a certain extent, we've been telling you in the homework, this is what you need to do and how you need to do it. And out in the real world, that's not how computer science works, right? They just tell you what you want done, and you have to go figure out how to do and what to do. And it was sort of, and through the course of the semester, we're progressing you to that. And there always is a big jump between the Luke's homework and the class's homework. And students always hate me for that week, and hopefully they get over it, but sometimes they don't. So we certainly will work on making them as clear as possible. To a certain extent, the vagueness there is intentional because we are purposely not telling you what to do. We're telling you what we want, and we're leaving it up to you to figure out what to do and how to do it. So I want to move from there. Yeah, this was an interesting comment. So this is homework 8. In homework 7, you created a location class and a person class. Oh, question?
Well, with so much like people depending on help from the TAs, our program's going to be more and more similar. And one of the TAs was saying that like your program, whatever that you have, you have to someone chooses. There's like a certain number of like percentage of code if it's like similar. If you have the same TA helping like different people, like how do you distinguish between that? Like for that homework, the TA was like, here, all 4 of y'all come. This is how I explain how y'all need to solve this problem.
Mm-hmm.
I mean, I wrote that in my comments, but how do you distinguish between that?
In terms of cheat checking or in terms of grading?
Yeah.
Okay. So that's not, I mean, anytime you have a class, that's actually more of a problem on the earlier homeworks, believe it or not. So on homework 1, it wasn't bike loops this semester. What was it? Weekday computation. When you think about it, looking back at it, all the first homework, it asks for input, it does a computation and prints out output. We have a couple other things, right? Like we print a pretty legends, we format it nicely, we echo the input, all that other stuff. But when you think about it, there's only a small number of ways that that program can be written. And there's a total of 375 people in this course, or I think it sounds about 350 because they all got mad and left. And when you have 350 people doing it, you all are all going to have similar programs. We realize that. And if your program is similar to somebody else's program, we realize that that's a concern, and we're not going to immediately accuse you of cheating. When your program is identical to somebody else's program, like byte for byte, then it becomes a bit obvious. Or, and this is really interesting, if you submit a program with somebody else's name because you forgot to edit the comments, that's not working. Yes, that's happened. You think if you're going to cheat and you got into UVA, you'd at least know how to cheat and change the name. You've heard the stories in high school where you white out the name and you write your name over it, and sometimes the teachers are fooled, and sometimes they just look on the back and see who actually did it the first time. So we realize that the programs are going to be similar, and we're not, ultimately we're not, just the fact that your program is similar to everyone else's program is not really a concern. Because when you think about it, we've told you all the methods to do, and so far the methods have all been short methods. And I mean short methods like 5 or 10 lines for the most part. Granted, game.job was a lot longer than that, but most of the methods were short, and the difficulty was, of course, is that we gave you like 10 million of them. So I'm not really worried about it. I think a human, a computer looking at it may say, hey, this program looks kind of similar, but a human who's experienced, I mean, like, you know, someone like me who's been doing this is my 6th, and actually last semester, teaching this class, somebody who's been seeing this for a while will be able to figure out that it's similar, but it's not a copy. Does that put your mind at ease? Okay.
So you're not going to teach us
I'm getting rotated off this class. I'm moving to 216. And I'm not, Professor Sullivan and Professor Humphreys are going to be the two people who are teaching it next semester. They like to rotate people through every 3 or 4 years, every 2 or 3 years. Burnout from comments like that. Yes?
With all these homeworks in the labs building off of each other, like if the code we submitted today doesn't compile and didn't run correctly, and that the code for needs to from that code, how is bringing that?
So the question was double jeopardy. What happens if you screw up on one homework and then you want to do the other homeworks? We take that into account, and what we will do is we will give you a precompiled version of homework 7. So we will actually give you the .class file for location and the .class file for person, and you can use ours if you so choose, or you can use yours. So we realize that I mean, it wouldn't be fair if you spazzed out on homework 7 to penalize you for all the successive ones. So each homework is going to be graded individually and not rely on the other homeworks. Obviously, if you want your entire game to work on your code solely alone, then you would have to go back and fix the problems. The other thing is, from time to time, we find various things we didn't explain properly in the lab, in the homeworks, or that we made a mistake or whatnot. And if you do want to have all your code run the game, as opposed to do each homework individually and then have our code run the game, there's going to be a list of things you have to go back and fix. They're pretty short. I think we misnamed the method, for example, which obviously we're not going to penalize you for homework 7, but there was a confusion between location class is alive versus get is alive. It was confusing as to which one was actually needed. Whichever one you put in, you'll get credit for, but if you want it to work with the successive ones, you'll have to go back and fix that. And that'll be your option. We're going to have a list of all that stuff as well.
For this homework also, it was like for the location class, it was like for post row and post column. It was like R and C, and like post row is for y-axis, and post pole is the x-axis, or x-coordinate, excuse me. Did you want to output like x and y or y and x?
Because it was basically y on the x.
Oh, did I mix those up again?
Coordinates were actually y. Which is fine.
You're not going to take points off of that?
No, we're not going to take points off. I mean, it's not, my goal in this class is to be hard but fair. And if I take points off because I got confused and I can't keep my x and y straight, and it's kind of not fair for me to start taking points off from you. So I would think either way you do it for this homework would work. I'll probably put that in my list of things that you just have to go back and fix. The thing is that Excel does the y-axis first, and I figured that most people would want to do the y-axis first. But then, after you said that, I realized that I probably did screw that up because apparently I can't keep my x and y straight. So you won't get any points off, and certainly in this homework. Other questions, comments, concerns? So how many people thought that homework 7 was difficult but fair? How many thought that I'm psychotic and it was so unfair? Okay, I'm seeing some. How many thought it was easy? I'm seeing some. Okay, so some people think I'm psychotic, some people think I'm easy. I think successive homeworks will at least be out a full week ahead of time, so that should make it a bit easier to deal with. So we have a whole slew of classes that we need to do. And we've done 2 of them, right? Location, which, remember that our map is going to be a nice 2D grid. And person, which is going to be one of the 4 or 5 people in your party. And the person has things, I mean, you've seen the person properties, right? It has health. So if you get struck by lightning, it costs like 20 points of health, and poof, you're dead. Or typhoid costs 6 units of health, or something like that. You get to pick all those things, right? So you can choose if you want your people to get dysentery or not. So, and we have a whole number of classes that we're going to have to do in many of the successive homeworks and labs. We have done parser, which deals with obtaining all the input. We've done location, which is a location object, one of the say 100 or so locations, and of course a person. In this particular assignment, you're going to do the inventory class and the depot class. So Inventory holds goods. Those goods can be food, it can be ammunition, it can be oxen, or it can be money. And those are the 4 instance variables of inventory, is how much of those 4 goods it has. When I say oxen, it's actually some means of propulsion. It can be oxen, it can be horses, it can be rocket boosters. If you want to make this into a space-based game, you can have like rocket engines. And instead of going and buying oxen, you go and buy rocket engines. It's still going to be called oxen in the code, but in the game you can call it actually anything that you want. And then there's depot. A depot is like a market. Every location, as you saw, may or may not have a depot. And the depot itself is a place where you can buy and sell goods. That's pretty much all that it does. Think of it in the original game, it's like a fort. You can buy goods, you can sell goods, et cetera, et cetera. So a depot is going to have an inventory, right? These are the goods that it has available. It has 50 oxen for sale, and 1,000 units of food, and 20, boxes of ammunition, et cetera, et cetera. Eventually, we're going to see a vehicle object. And the vehicle object is what actually goes around to the various locations, and it has, among other things, the 5 people are in the vehicle object, and the inventory is in the vehicle object. So we're going to have a lot of inventories lying around. Every depot has its own inventory, and the one and only one vehicle object will also have its own inventory. And when you go into the depot and you decide to buy stuff, it's going to remove it from the depot's inventory and put it into the vehicle's inventory. So, right. Here you'll notice that we provide you with a location.class, which, to answer your question, is a precompiled version of the location. We think it's generally bug-free. We hope it's generally bug-free. Parser.class from the lab. And for this particular homework, you don't need the person.class. That's why it's not there. There's a game.java, so we have a whole slew of constants here. And these constants are basically, they control how well the game works. So for example, how difficult is it to move through mountains? How difficult is it to move through grassland? How much do oxen cost, or rocket engines, or whatever you want to call them? And this is what all of these constants control. And I actually, 2 of my TAs, I've assigned them the task of playing the game over and over, and they're actually going to figure out sort of reasonable values for it. Because as you saw when I gave the demo a week ago, you could buy 50, or you could buy like 100 oxen and enough food to travel to Oregon and back and forth and back. So it turns out that something like 24 or 36 constants. We're going to sort of be introducing them to you somewhat slowly. We saw a bunch with the first assignment. We've seen some more here, like default food amount, default oxen amount, default ammo amount. They weren't in the homework 7 game.java, but they're in the homework 8 game.java. Question?
If you did want to use different like landscapes and stuff, do you want us to wait until like we implemented everything before we change like
if you want to use different landscapes, you should not change any of the stuff here. As far as the game is concerned, so there's going to be another class called Descriptions, which I think is going to be next week's lab. And in that one, you're going to choose the names for your landscapes. You can choose, if you want to walk around UVA, it can be dorm room or, athletic stadium or classroom, and you go from one to the other. Or, I don't know, anything that you want. But there will be a specific time for you to do that. You shouldn't change any of the variables there, because when we run it through our grading system, it's specifically going to look for movement cost mountain, not movement cost like empty space. So these variables should not change. Just like the get oxen method in the inventory should still say get oxen, even if it really means rocket engines. So then, blah, blah, blah. Inventory class just has 4 variables, the 4 things that you can trade: money, ammo, food, and your means of propulsion, oxen. And there's a number of methods that you need to do in addition to the accessors and the mutators. These methods are generally short methods. they could all be done in under 10 lines. Things like add item amount. So we're going to have a set oxen method and a get oxen method. This reads in an item. That item, for example, is going to be one of these, money, food, ammo, or oxen. And then the add item will just add this many to that particular field. So you have a switch, right? Switch on the item. If it's food pos, then you add that much to the money. If it's money, if it's food, then you add that much, you call set food, et cetera, et cetera. So most of these are going to be fairly short methods. They shouldn't be too tremendously long. And that's the inventory class. Next class is depot class. Depot has a number of, has 4 properties. The first is price factor. What we've done is, if you actually played the original game, the further you get away from where you start, or the closer you get to Oregon, things become more and more expensive. We do this by assigning a price factor in the inventory. And if a price factor is 2, then things are twice as much as if a place where the price factor is 1. Location, my location, that is where the depot is stored, or where the depot is. So every location needs to have a pointer to its depot, and the depot needs to have a pointer back to its location. String name, it's going to be the name of those locations. The TAs who are being paid to play the game, will actually go through, and we're going to have a list of the actual Oregon Trail forts. There's Fort Hall, Fort this, Fort that, Fort the other thing. Or you can make up star-based names, UVA dorm names, anything you want. But that's going to be some randomly assigned name or somehow assigned name based on the ones that you choose this Thursday or next Thursday. An inventory, that's the objects that the depot has. Right, we have constructors, we have accessors, we have mutators. And then there are a total of 4 methods you have to implement. The first one is easy. It's just print a couple lines. The next 3, however, are kind of doozies. So we are giving you some skeleton code for this. And so buy item, that is when you're in a depot and you've chosen to buy a particular item. So when that's called, what it does is first it has to figure out what item you want to buy. And the way it does that is it calls a parser method. Then it figures out how many it figures out how many of the item you want to buy. Again, another method in the parser class. And then it removes that from the depot's inventory and adds that to your inventory. And we actually sort of explain the steps there. Sell item is something similar. Finds out what item you want to sell, how much you want to sell, removes it from your inventory, adds it to the depot's inventory. There's a couple other things that have to happen too, right? We have to make sure there's enough in the inventory to buy or sell, and make sure there's enough money, et cetera, et cetera. As you're going through this, because there certainly are a lot of steps in these methods, as you're going through it, do the steps one by one. It will save you so much frustration, and you won't have to resort to sending me really nice comments like I showed before. If you go one by one, like first of all, prompt the user for an item choice. Implement that. Then make sure it works. Run it through a couple times. Try a couple item choices. Print out the results. So then you know that that works. Go to the next step. Prompt the user for an amount. And then your method can just say you want to buy 27 oxen. And if you go through it step by step, it's going to save you a huge amount of headache. You try writing the method all at once, all in one go, it will not work. You will be very frustrated. You will send me more nasty messages. I guarantee if you do it step by step, it'll be much easier. So those are the other methods that we have to do. Then, of course, we have to write the game class and actually check it to make sure it works. Questions, comments, concerns, hate mail? Okay. So I wanted to start talking about arrays. We're going to spend some time, we're going to probably spend about 2 weeks worth of lectures talking about arrays. As you can see, the Friday lectures, about half of it's going to be taken up by me discussing the homework, perhaps apologizing for the previous homework. Arrays we're going to talk about, an array is like a collection, like a vector. It allows you to store many things. In the same way that when we create a vector, we can store 1,000 string objects or 1,000 circle objects or anything we want, we're going to be able to do similar things with arrays. Introduction to arrays. So, rah, blah, 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 blah. What this is saying is obviously there are many times that we need to store things such as strings or circles, or as we're going to see, location objects. We're going to need to store 100 location objects. Our party class that we're going to implement later needs to store 5 people objects. So, and that's essentially the purpose of arrays. If I was to have a program, or one of my programs that manages all the grading, needs to store 375 student objects. And each student object is you, right? The properties are your name, your address, et cetera, et cetera.
Why would you use a vector over array?
I'm sorry?
Why would you use vector over array?
So the question is, why would you use a vector over arrays? There are pros and there are cons to each. Ultimately, vectors are implemented using arrays, and that's why I want to show you so that you actually understand how it works. There are a lot of benefits to using arrays that we're going to see. Once we finish, I'll spend some time talking about it. But one of the classes I'm going to show at the end of the slide set is I'm actually going to show you how the vector class is implemented. We'll go through and I'll explain the entire vector class and how it deals with adding and deals with, because a vector class, you don't have to care about capacity. We're going to see how that works as well. This is how you declare an array, or it's one way to declare an array. Or you can declare it that way. And you notice we have the bracket bracket. And that's generally, but not always, next to the type. So char C is going to create an array that is empty. And I'll explain exactly what that means in a second. This is going to create an array of size 10. The second one creates an array that is has spots for 10 elements inside it. Arrays are objects, meaning when you do this and you say char C, well, actually, let's look at the second one. It creates a value reference, and that value reference points to some array object. And it can hold a total of 10 integers. So when I just say char C, that does create some reference C that can eventually point to an array, but doesn't yet. It's uninitialized, maybe it's null, depending on where it's created. So what happens here is that this creates 10 spots, so value is a reference. It points to some list of 10 spots. Each can hold integers. The way Java works, sometimes it initializes things, sometimes it doesn't. In arrays, everything is initialized to default values. So here are 10 integers all initialized to 0. And that's what it looks like. Value is a reference to, imagine there's 5 more going off underneath the periodic table. And C is a reference, but it doesn't actually point anywhere. So a couple other things to keep in mind. The brackets need to be on the left and the right. On the left, this int bracket bracket is saying that it's not an int that we're going to be creating, but an int array. And on the right, I'm saying I'm creating a new int array of size 10. Once you create an array of size 10, you can never, ever change that array. It will always be size 10 for its entire life. This is a restriction that we're going to see ways to bypass it later on. So let's look at this code. Int b equals new int 10. In reality, what is actually happening, let's see, I'm going to do like a blue, is that's creating a b reference that points to some array of 10 elements. This ends up, I want you to keep in mind that this is actually how memory looks like, but this will often be a bit clunky and difficult to do on the slides, so you'll just sort of see something like that. This is the V array of 10 elements. In reality, V is a reference to the array. I'm going to ignore that for this slide. Here, we just have things that indicate the index, so as I'm showing this to you, it's easy to figure out which is which. So int I equals 7, int j equals 2, and int k is 4, right? That's just creating regular int variables. B0 equals 1. Ooh, it's sunny in 44. B0, this is how you actually access an element in the array. Inside brackets, you have some integer. It can be a variable. It can be a actual number. But V0 means the first element in the array. Just like vectors, just like strings, it all starts from 0. So when I say V0 equals 1, here, my spot V0 is set equal to 1. Vi equals 5. Well, I is 7. So V7 is set equal to 5. This first looks at the right side. I is 7. V sub I is 5. So 5 plus 3 is 8, and it's going to set V sub j to 8. Well, j is 2, so here we have V sub 2 is set equal to 8. Again, it looks at the right side first. V sub I is 7, V sub I is 5. 5 plus 1 is 6. V sub 3 is set equal to 6. Notice here that we're putting an index inside an index. Like parentheses, it looks at the innermost one first. J is 2. V sub j is the equivalent of V sub 2. V sub 2 is 8. So this is going to set V sub 8 equal to 12. And that's right there as being set equal to 12. We can print out a particular spot in the array. So this is printing out V sub 2, which is printing out 8. Or we can read in things into the array. So this is sort of a basic primer on using arrays. First you create it, you stick values in it, and then you can start manipulating those values. Questions on this? Yes? This one? So first what we do is brackets are sort of like parentheses in that, we look at the innermost one first. So first looks at j, and j is 2. So this is going to be the equivalent of v sub 2. Now it looks at that much, and it looks, v sub 2 is 8. So what's going to happen here is it's going to look at v sub, well, it's going to look at it that way. V sub 8 equals 12. Well, V sub 8 is here, and it's going to set V sub 8 to 12. So work from the innermost one first and work out from there, just like you would with parentheses. Other questions? All right. How many people feel they sort of understand this? Good. I'm seeing a good number of hands. Huh. All right. Give me. It's the longest slide transition I've ever seen. Okay. So without initialization, I say element type, bracket, bracket, ID. Element type can be anything. So far we've seen primitive types. You can have an array of strings, an array of circles, an array of locations. So that's whatever we're going to keep in the list. The brackets tell Java that, hey, we're dealing with arrays here. And ID is just the name of it, like the name of a variable. And this, of course, does something like this. We'll either set it to uninitialized or null, depending on where you declare it. So int bracket bracket a, it turns out it's the same thing as int a bracket bracket. This is why occasionally you'll see me public static void main string bracket bracket args. You could also say public static void main string args bracket bracket. It doesn't really matter. There is a minor difference between them, but we're not going to care about that difference really in this course. So where you put the brackets, it's probably better to get in the habit of putting them first. I'm in sort of a bad habit, and I tend to put them second. Let me rephrase that. If you're not sure what the difference is, you should always put them first. So I don't want to talk about the difference now. With initialization, it looks like that. Element type, bracket bracket ID equals new element type bracket n. N is some non-negative integer. It can be 0, it can be 1, it can be a billion, although I don't think your computer will have that much memory. And it's going to create a new array of that length. ID is going to be a reference to some list of elements or some array of elements that's n units or n long.
Is it possible to use more than one type in an array?
The question is it possible to use more than one type in array? For now, no. We will see on the last day of class that there are ways to get around that when we talk about inheritance. But at this point, no, you cannot use more than one type in an array. You declare an int array, you can only put ints into that array. A string array, you can only put strings into that array. That's going to change a bit later on.
If we don't put a number inside the brackets, then can we set it later?
The question is, if you don't put a number inside the brackets, can you set it later? Java will not allow you to change the type, the size of the array. What you can later do, so let's say value was declared. I can later say value equals new int 5. So I've declared this. I said int bracket bracket value equals new int bracket 10 close bracket somewhere previously. Later on, I can say this, value equals new int 5. What that's doing is that's creating a new array and changing, need my eraser, making the reference value point to that new array. So what I said before is that the original array is still there and it's still 10 elements long. But now value is pointing to a different array, which happens to be 5. So from the point of the user, yeah, it looks like value changed its size. But in reality, it's just pointing to a different array. This then gets garbage collected away, and any values that were there are lost. So you can't actually change this array, or the size of this array, but you can make it point to a brand new array. Yes?
For the ID, is it always ID for every array you make?
No, it's some sort of identifier. It's anything you want. Right. So that creates a new array of n elements. So we've seen arrays before, and we've seen them quite a bit, although we've sort of hid that. This is the last part of the main method that I told you on day one I would eventually tell you about. That is the last part of that main method. We've seen public, we've seen static, we've seen void, we've seen string, we've seen parameters. Now we're seeing the bracket bracket. And what this is saying is that every time the main method is called, that a string array is passed into it. How to populate that array, meaning how to actually stick elements into that array when the main method is called, I'm going to show you a bit later on in the slide set. But basically, this main method, or any main method, takes in a string array as the parameter. And as I said, you can also define it that way. When Java looks at a parameter list, it doesn't care what you call the parameter. So you can rename it to anything you want. As long as the type is a string array, you could call it foo, foobar, args, arguments, parameter, I mean anything that you want. All Java cares about is that the one and only parameter to the main method is a string array. What it's called, Java couldn't care less. We call it args for a reason that we're going to see in that's sort of the most common name to call it. We're going to see why we call it that probably on Monday or Wednesday. Okay. Okay, it's coming up. So any array is composed of, you declare an array of size 10, you have 10 elements. Those are the basic parts of the array, if you will. Elements have a common name. I could say value sub 0, value sub 1, value sub 2, value sub 3, value sub 4. The common name is value. It allows us with a different index to access any particular element inside our array. Right? A sub 3 equals 5. Here, any element in this A array can be accessed by A bracket, some number, close bracket. We can access the entire array just by calling A, and we'll see why we actually care about that in a bit. And to answer the other question that was brought up, for now, all elements in arrays always have to be the same type. You can't mix ints and doubles in your array. So when you're actually reading it, this is called a subscript or an index. And it's often read A sub 3, meaning element at index 3 in the array A. Of course, index 3 is actually the fourth element because it starts from 0. So this is often read as A sub 3. So the brackets, of course, do the subscripting, blah, 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 blah. So for those who have seen C, actually, most of this stuff you don't really care too much about. There's a couple things that I want to briefly mention here, and we're going to, actually, I'll give you a second or two to read all the gibberish on the slide. 5, 4, 3, 2, 1. Okay, so a couple things that I do want to point out, the important things on this. Automatic bounds checking is something that is really, really useful. What it means is that if you have an array of size 10, and you try to access the index at element 15, Java will tell you that you've tried to do that. It's called an array out of bounds exception. Because if you have if your array is size 10, then it has indices 0 to 9. If you try to access element at index 15, there is no index 15, so Java is going to complain. Whereas other programming languages will crash and not tell you why, Java will crash and tell you why. And the fact that it tells you actually is very useful. Arrays are objects. We're going to spend some time talking about this, et cetera, et cetera. Okay. So I was sitting there getting ready for class today, and there was this link online that was talking about this polar bear cub in the Berlin Zoo. How many people have heard about this? Okay. So this one circus had a polar bear cub, had a polar bear, because circuses, circi, are wont to do that. And the polar bear gave birth to a pair of cubs. One died pretty quickly, and the other one was abandoned by the mother. So they took this in the Berlin Zoo, and this one guy that we're going to see in a second has sort of been raising it. And this is to create a media sensation. Like, everybody's going to the Berlin Zoo, the stock prices shot up, everyone's all excited. Politicians are showing up, trying to be inside the pictures. So I wanted to show you. So I'm such a softie for animals, and I thought this was really cool. So we get a brief ad. If you want to get your money out of the country legally, use Zurich Swiss Bank.
At the moment, every day is Tuesday in Berlin. The German capital's baby polar bear is now 3.5 months old and already weighs 9.3 kilos. And he's become a superstar. Around 500 journalists and 100 cameras from around the world turned up at Berlin Zoo last Friday to report on the furry little guy's first public appearance. Q was accompanied by the German Environment Minister, Berlin Zoo Director, and his carer Thomas Hörflein. The lovable little furball is the first polar bear to be born at the zoo in 33 years. His mother Tosja, who was a circus performer in East Germany, rejected him, so Hörflein has spent the past 3 months rearing Knuti with the bottles.
Alle jungen Bären
All young bears display distinct childlike characteristics. To us, even grown-up bears are nice and cute. But young bears have this short nose and round head and big paws. Everyone loves it. There is no one who could say that he's not cute, but he's not nice.
die schöner ist die Ed.
For a short time last week, Cute Knut was the subject of controversy here in Germany after animal rights activists demanded he be put down. The young polar bear wasn't being reared in a way that was appropriate for his species, they argued. This provoked a collective outcry from animal lovers around the world. Militant polar bear fans from England even threatened by email to send in troops if anything happened to Knut. Knut can now be seen every day between 11 a.m. and 1 p.m. at the Berlin Zoo. And, as he already proved on his debut appearance, he is a true professional when it comes to entertaining crowds.
So there's actually, if you go to YouTube and you type his name, K-N-U-T, there's actually a whole slew of videos. This is there somewhere as well. And they've actually made a music video, which the song they sing is Bare Necessities. And they have some additional footage, which is kind of cool, although they end up reusing that because they wanted to make an 8-minute clip and only had 6 minutes of footage. Anyway, but if you're interested, you can just do a Google news search for Canute or a YouTube search for it, and it comes up with a whole slew of videos. And I will see you all on Monday. Have a great weekend.